what's going on everybody? The networking guru here at Trepa Technologies, and today we're going over domain 5.3 of our Network Plus full and free course. If you like this content, like, subscribe, share with your friends. Let's go ahead and jump right into it. So again, we're going over domain 5.3, which is going to be given a scenario, troubleshoot common issues of network services. And what do we mean by network services is that layer 2, layer 3. That's what we're going to troubleshoot today. So first we're going to start off with switching issues. These are all the exam objectives in domain 5.3. We'll go into route selections, we're going to cover a routing table and default routes. Remember back in domain 2, we did a deep dive on switching and routing. Probably combined like 2.5 hours worth of video content. So I'm just going to go through the issues here. I'm not going to take another 30 minutes to describe spanning tree protocol. I'm not going to take another 30 minutes to describe routing and routing protocols. We're just going to go over common things that can occur. And then we're going to go into IP addressing issues that are so simple, but as that tier 1, level 1 NOC engineer, this is going to happen to you. And you have to start at that low level and be like, well, is the subnet mask wrong? So let's go ahead and jump into it. So we're going to start off with switching issues and spanning tree protocol. So remember what the spanning tree protocol does. It prevents something called a switching loop, which essentially means that switches will keep forwarding broadcast frames to each other with no end, throttling their CPU, and you won't have any connection. You'll have what's called a broadcast storm. You see my mad little cloud there? It's pissed off. It's a broadcast storm, right? And now the network is down. The frames circulate endlessly, consuming bandwidth, bringing the network to a halt, throttling the CPU. It's bad stuff, guys. It's bad stuff. What spanning tree does do is ensure that that redundant path that causes that loop is sent, one side of those links is sent into a discarding or alternate state. So it's not actually going to be forwarding traffic, okay? And then it's just going to have one path to what's called the root bridge. That's the king of the castle or queen of the castle that's going to say, hey, send all traffic to me in our switching environment. So once that root bridge is established, we have to establish the path to it. So then all the non-root bridges or switches are going to say, what's my root port? My root port's how I'm going to forward to the root bridge. And then we become fully synchronized, right? Fully converged. When we decide wherever that redundant path is, we're going to send that into an alternate or discarding state or blocking state, okay? We do this by sending out BPDUs and going by a certain metric. So the root bridge is elected by the lowest bridge priority, which is part of the BPDU. That's going to be the lowest number in increments of 4,096. So 0, 4,096, 8,192, and then increments of 4,096 are going to be our bridge ID. Now, if all switches have the same bridge ID, we're going to go into a tiebreaker. That tiebreaker is going to be the lowest BPDU, bridge ID total is going to be the MAC address. So the lowest MAC address is then the tiebreaker if all bridge IDs are the same. Okay, like we all left them at default, 32,768. If all our switches are the default, bridge ID, lowest MAC address. And then once we elect the root bridge, then we just select the roles and the states. We select the path to the root bridge, okay? We do that based on cost, so lowest cost. Now, the higher the bandwidth, the interface on the bandwidth, the lower the cost. So if I have gigabit or 10 gigabit, that's going to be a lower cost, with 10 gigabit being a cost of 2 according to spanning tree, gigabit being a cost of 4 according to spanning tree, and fast ethernet being a cost of 19. So whatever has the lowest cost, our non-root bridge switches are going to say, that's my root port, the lowest cost of the root bridge. And then we elect the blocking port to kill that redundancy. However, the beauty of spanning tree is that if, let's say, our root port, that path comes down, like we shut it down on accident, a cable gets stepped on, whatever the case may be, that doesn't mean that blocking port's going to stay blocking forever. We can reconverge because we're sending BPDUs all the time in our switch environment that says, hey, never mind, that blocking port now has to go into a forwarding state because we lost our root port, okay? So, the troubleshooting part. If we have notice we have a broadcast storm, that means we need to go troubleshoot spanning tree, right? We need to make sure that we have spanning tree enabled. Someone hasn't disabled spanning tree on a trunk port. Because we do disable spanning tree on our access ports because we don't need BPDUs being sent to users, and we don't want a malicious user sending a superior BPDU telling the network that this user's Kali Linux box is, the root bridge. We don't need that. So we usually disable it on all of our access ports. But if someone disables spanning tree on a trunk port, we could have that issue. If someone, like one of our junior admins, plugs in an old switch, and that old switch has a bridge ID of 0, and then all of a sudden that old switch is supporting like 5 users in some random part of our campus area, and now all traffic's getting forwarded there, and we notice some serious lag. It's an issue, right? So that's our spanning tree issues. Another thing we're going to go over here is the port roles and port states. So in spanning tree and rapid spanning tree are roles. The root port role is going to be how we forward to the root bridge. If we are the root bridge, we don't have a root port. And the state of that root port is always forwarding. So a root port equals forwarding, sending traffic. Then we have a designated port. This is going to be the same in regular spanning tree and rapid spanning tree. The designated port is not necessarily pointing towards the root bridge, but it's still going to be forwarding traffic, okay? It's going to be in a forwarding state. So like our access ports to our users, if spanning tree is still on that port, it's just going to be designated. It's going to be forwarding, right? Let me pause the video. Let me show you that. So we're on our switch here. So if I type in show spanning tree, we can see we have designated ports here. And this is the root bridge. So as the root bridge, we're going to have old designated port roles, and they're all going to be in a state of forwarding. Like these are to my users too, right? So these are to my user interfaces. They probably shouldn't be participating in spanning tree. It's okay. I'll show you a command to make sure BPDs don't get sent out there. But they're designated state because spanning tree looks at them and says, no, you still need to be forwarding. You're not a root port. You're not the port we're going to use to send old traffic to the root bridge, but you're still in a forwarding state. So if I come here, Control C, I go into global config, type in interface gig 6/0/41. If I type in spanning tree port fast, that disables spanning tree. So we're not going to be sending BPDUs out that port anymore. So you can read this here to a single host, right? If you do this on your trunk interface, you're going to cause potentially a bridging loop. All right, let's get back to our slides here. Just want to show you that. And then the non-designated port or the alternate or backup port, that's going to be in a blocking and discarding state. Blocking for regular spanning tree, discarding for rapid spanning tree. Means the same thing. They just gave it a different name, right? But what's different with rapid spanning tree is that non-designated port becomes a backup. So if our root port fails, like physically comes down, whatever the case may be, this is our backup port, right? Or that becomes a designated port, whatever the case may be. And then we just have disabled, right, discarding. All right, so more switching issues. We could have VLAN misassignments, okay? So we could have something like this, where we came to this user, we gave it an IP address within VLAN 10 here. Do we see that? 10.10.10.0/24. So we gave it an IP address within that subnet, but then at the actual switch, we put in the wrong VLAN. We put in VLAN 20. So now we're going to be tagging this Ethernet frame with a VLAN 20 that's actually part of this broadcast domain, and this user will have no connectivity. And let's say we went in there and statically set this, right? Instead of using DHCP, that'd be an issue. So the problem, we assigned the wrong VLAN to the switch port based on the user and that user's requirements. Resolution, let's go check, and let's switch it, right? So how can we check that on like a Cisco switch? I'm going to come back here. So what we can do, if we're at like enabled mode here, we can type in show run interface gig 6/0/20. Okay, that's the wrong VLAN. We also have a command like this, do show VLAN brief. We can say, oh, it's 20. This needs to be in VLAN 10. So now let's go into that port. We'll type in switch port access VLAN 10. And now our make-believe computer here that's supposed to be in VLAN 10 should be good to go. Another way to check is we can look at the running config, right? And there we go. Or not another way, that's how we can check, okay? And now we fixed that. Another issue we could have is ACLs. Someone applied an ACL on a junior admin applied an ACL, and now all of a sudden the user can't reach the web server. So this is part of our troubleshooting steps. If this user could ping this web server, but they can't get on the, let's say there's a SharePoint portal, but they can ping it, but they can't get in the SharePoint portal, DNS is working, someone must have denied port 443. We can't reach it via HTTPS, right? So ACL. So ACLs filter traffic based on rules applied to network devices, source, destination, IP, port, and protocol, right? For our standard ACLs that aren't doing deep packet inspection like on our next generation firewalls. So we just got to verify ACL rules, okay? We can do that with this command here, do show access list. That'll show you all the access lists and their rules. But if we want to see how an access list is applied, we could just go to the interface itself and see if it's applied, right? Inbound or outbound. That's how we would check how and where it's applied. All right, so let's take a breath. Let's jump into routing now. Let's go into route selection issues. So a routing table. So a global routing table, that's the brain of a router. When a router receives a packet with a destination IP, and that destination IP is outside of the LAN, right? So that's why it got sent to the router in the first place, default gateway. It's going to look at that destination IP. It's going to reference that destination IP to our routing table. And if there's not a route in that routing table for that destination IP, that router's dropping it, okay? So route selection issues. If a user can't reach like a distant end, let's say we have 2 spoke offices and users cannot talk to each other. If we start troubleshooting from the routing perspective, we would type in something like show IP route and see if there's a route to each other. Now, what we like to have, just in case, is something called a default route, where we say, hey, we're going to have specific routes. So in this one, if we want to talk to 172.16.144.10, so an IP address within this subnet here, right? We're going to go out and we're going to send traffic to here. We're going to send traffic out our fast Ethernet interface, and the next hop is going to be 10.1.124.4. So if a user comes in and they want to talk to 172.16.144.10 that's in their packet's destination IP header, we're forwarding that packet to the next hop IP of 10.1.124.4 out fast Ethernet 10. Now let's say a user comes in and they want to talk to 4.4.4.4. Okay? So user wants to talk to destination IP 4.4.4.4. If we didn't have this default gateway, this last resort, let's say we didn't have this. So imagine that's not there. And this is all the options, all the things the router knows about, and we're trying to reach 4.4.4.4. What would happen? We couldn't. We'd discard that packet because we'd reference our routing table and say, there's no specific route here that exists, so drop it. A default route stops that. A default route, depending on how your network's built in scenarios, like a stub network is the best scenario for it, where you only have one ISP out, or all these are like over tunnels, and then you have your direct ISP connection. You want that default route that's a catch-all. It says, hey, if we don't have something more specific here, go out this default route out serial 0/1. Okay, now let's get into some basic IP addressing issues. So, address pool exhaustion. So let's say we have a DHCP server, and that pool is a /27, which means we can only assign 30 usable IPs. And then we have the 31st user plugs in their computer. And we notice as a network admin, that they're getting an APIPA address. If we see this, a 169.254.00 through 169.254.255.255, that means A, DHCP is not working, or our pools are exhausted, and now that Windows computer, this is a Windows thing, right, is self-assigning it an IP address, okay? That's an APIPA address. So we can have this issue. So if we see an APIPA address, first thing we want to start troubleshooting is, one, our connection to the DHCP server from that user. Are they in the right VLAN, things like that. But then at the actual DHCP server itself, do we have enough IP addressing, or is our pool exhausted? Another issue we could have is incorrect default gateway. So let's say we're assigning things statically, and we give this computer a good IP address, the correct subnet mask, but the default gateway is 10.0.0.1, and we put the default gateway that would be right above this network, 10.0.0.3. We would have an issue here. Best way to resolve this is just go to the user and fix it, right? Or maybe we put in the DHCP pool the wrong default gateway to assign to users. We have to fix it at the DHCP pool. Incorrect IP address. So again, let's say we need a user within this network here, 10.0.0.0/27. That means the user would be assigned an IP address of .2 to .30. And we assign this user .35. That's outside that subnet range, so we're not going to be able to talk. Duplicate. So let's say we have a duplicate IP address. Let me get my face out of here. Let's say we assign a static IP here, but didn't reserve it in this pool. So the pool still believes that can be sent out, and it doesn't do its checks, whatever. And the DHCP assigns this IP address. That could be an issue. Now, typically this doesn't happen because DHCP will... anyways, I don't want to dive too deep into it. But this could also just be an admin error. Let's say we have 2 printers, And typically printers, VTC machines, file shares like NAS, they get static IPs. Let's just say we do it on accident. We'll get a duplicate IP address and we won't be able to send traffic. Troubleshooting, we can use things like ping or ARP, right, to identify duplicate IP. So if we ping and then we get a weird error back, we'll be like, whoa, that should be online. Let's go check, right? ARP will also be capable of doing this. In the router and switch console on Cisco devices, it'll tell you sometimes when there's a duplicate IP address in the MAC address for it as well. And then encrypt subnet mask. So right here, we have again this user. It's in the 10.0.0/27 network. So good IP address, good default gateway, but we gave it a /28. That's going to mess us up because that doesn't work. If we're 10.0.0.25 as /28, that means our range is .16 to .31 when we should be in the network .0 to .31 total network, right? The /27 here. All right, let's go ahead now and do our domain quiz. All right, so we're at our Academy site here. If you want access to this, click that link in the description below to get all these features that we offer. We have a mobile application as well for you to study and pass your certs. Let's go to our lessons here. Actually, let's just go to our quizzes here. And we're at domain 5.3.1. So let's go to 5.3.1 and start this quiz. Now let me zoom in so you don't have to squint when you're watching this video. Let me get my face over here and let's go ahead and do it. So question 1. Which of the following STP port states allows a port to learn MAC addresses but does not yet forward data frames? So we actually didn't touch on this in the slide, so I love when my questions double down on me, right? It's good, so we don't miss it. That's going to be learning. So the learning phase, okay? So the learning state in STP is used to build a MAC address table by learning source MAC addresses before we start full convergence and forwarding, right? You can read the explanation if you want. Pause the video. Question 2. If a port on a switch is in a blocking state, what is its function in the network? So it's preventing the loop, right? It's preventing loops by not forwarding or receiving frames. The whole point of spanning tree, right? Pause the video if you'd like to read the explanation. Question 3. If two devices on the same network have been mistakenly assigned the same IP address, what type of issue is likely to occur? That's an IP address conflict, right? That's just duplicate IP. Pause the video if you'd like to read this explanation. Question 4. What is the main purpose of the spanning tree protocol in a network? That's to prevent broadcast storms, baby. No more switching or network loops. Elect that root bridge, determine the root ports. Let's go. Pause the video if you'd like to read the explanation. Question 5. Which of the following is a likely cause if a device cannot communicate outside its own network but can communicate with devices within the same subnet? Okay, break that down. So it can't talk outside of its own network but can communicate devices within the same subnet. So that means when we talk outside our subnet, guys, we forward traffic to our default gateway, and that's our routing device that'll reference a routing table and say, where do you need to go? Speak, okay? They have an incorrect default gateway assigned. Go ahead and pause the video if you'd like to read that explanation. Question 6. What might happen if a network experiences address pool exhaustion? So C, right? New devices won't receive an IP address from the DHCP server. That's it. They don't got it. We're out, buddy. We don't got IP addresses. There's our explanation. Pause the video if you'd like to read. And let's go, baby. We got 100%. I want to thank everyone for viewing. Don't forget to like, subscribe, share with your friends if you enjoyed this content. And if you want access to our learning management system, hit the link in the description below. Pay for our virtual training, our self-paced training. If you're in the Army, it's free. Contact us if you want to hear more. And I'll see you in the next video.